Welcome back to the deep dive. Today we are popping the hood on a machine that usually stays very, very locked down.
Yeah, highly restricted.
Right. We're talking about a paper from Meta AI. It's called OPT, Open Pre-trained Transformer Language Models.
Open pre-trained transformers.
Yeah.
It is, it's a bit of a mouthful.
It kind of sounds like a car part you'd order off eBay or something.
Yeah, it does.
But this is actually a massive deal in the world of artificial intelligence. I mean, it represents a pretty radical shift in how we access and honestly how we understand these giant brains we call large language models.
It really is a pivotal moment.
Yeah.
For the last few years, the biggest, most powerful AI models, like GPT-3, for example, were essentially black boxes.
Right, completely sealed off.
Exactly. We knew they worked. We could see the output, but we weren't allowed to see how the sausage was made, so to speak.
Right. I've actually heard this described like the Ferrari problem.
The Ferrari problem.
Yeah, so imagine
Right.
Ferrari builds the fastest car on Earth, and they let you drive it. You can feel the speed, you can steer it around the track.
Right.
But if you pull into the pit stop and say, hey, can I pop the hood to see how the engine generates that much torque?
Right.
Or like, why does it make that weird clunking noise when I turn left? They just say, absolutely not. Just pay the subscription fee and keep driving.
That is actually a surprisingly accurate analogy. And that sealed hood is a massive problem for science.
Mm-hmm.
Because if you can't inspect the engine, which in this case means the weights and the parameters of the model,
Yeah.
you can't fully understand why it behaves the way it does.
You're just sort of poking the black box from the outside.
Exactly. You can't investigate why it has biases or why it fails in certain edge cases.
Yeah.
You are strictly a user. You are not a researcher.
So enter Meta AI. Their mission with the paper wasn't just to build another big model. Their mission was to build a replica of GPT-3 and then just give it away.
To researchers specifically, so academic researchers, government organizations, civil society, and non-commercial industry labs.
Basically, anyone who isn't trying to sell it.
Right. The goal was to break the monopoly on who gets to study these things.
But we aren't just talking about a thumb drive with some code on it. We are talking about an entire suite of models, ranging from 125 million parameters all the way up to the big kahuna, which is 175 billion parameters.
Which is the exact same scale as the famous GPT-3 model. They wanted to prove they could match it pound for pound.
So today we are going to deep dive into what makes OPT special. We're going to look at their logbook, which is basically a diary of all their failures. Spoiler alert, it's really messy.
Very messy.
We'll talk about the environmental cost, which is a huge topic.
Yeah.
And of course, the fun stuff. So like poetry that doesn't rhyme and math that just doesn't add up.
There is a lot to unpack here. But I think we should start with that open philosophy you mentioned.
Yeah, let's start there. Because usually when a big tech company builds a supermodel, they keep it strictly behind an API. Why did Meta decide to just hand this over?
Well, the paper puts it quite bluntly. They argue that restricted access has limited researchers' ability to study how and why these large language models work. If you are an academic trying to study toxicity in AI or robustness, you can't really do a deep analysis if you can't touch the actual model weights.
It's the difference between studying a tiger in the wild through binoculars versus actually doing an MRI on its brain.
That's a vivid image,
Yeah.
but yes, exactly. Meta released the 175 billion parameter model to bring more voices to the table. They wanted the broader community to help define the risks rather than just trusting a corporate safety team to do it all behind closed doors.
And this is where it gets really interesting to me, because they didn't just release the finished product, they released the logbook.
This is fascinating.
Right. Usually AI papers are these polished, perfect documents, like we built this thing, it works perfectly, here's the math.
Yeah, they make it look entirely effortless. But the OPT team released their daily notes. It's like the gritty, behind-the-scenes documentary of a band on tour where just everything goes wrong.
It turns out training a 175 billion parameter model is an absolute nightmare. It is not for the faint of heart.
Not at all.
I was looking at the stats in the source material. They faced massive hardware failures. Over the course of 2 months of training, they had 35 manual restarts.
Let's pause on that for a second, because a manual restart isn't just clicking refresh on your browser.
Right.
That means the training run crashed so hard that a human engineer had to physically intervene, diagnose the problem, fix the cluster, and restart the entire process from the last checkpoint.
35 times in 2 months. And they had to cycle out over 100 hosts, basically the computers holding the GPUs, because they just kept failing.
Think about that scale. We aren't talking about your laptop crashing.
Oh.
We're talking about a cluster of supercomputers where the hardware itself is practically buckling under the intense pressure of the computation.
It's wild.
It really highlights the human overhead and the massive infrastructure instability required to build these things.
It sounds like keeping an old car running while driving 100 miles an hour. You're just swapping out parts while the engine is running.
Precisely. And that transparency is so valuable because it shows the rest of the scientific community what the actual cost of entry is.
It's not just buying the chips.
Right. It's the operational headache. If you don't have an entire team of engineers ready to fix 35 critical crashes in 2 months, you simply can't train this model.
Speaking of cost, let's pivot to the environmental cost, because that's the other big reason for this open approach, right? These things eat electricity for breakfast.
They absolutely do. Training a large language model is incredibly energy intensive, but this is one area where the OPT team really flexed their engineering muscles. They developed OPT-175B with only 1/7 the carbon footprint of GPT-3.
Whoa. 1/7. That is a massive reduction. How did they pull that off?
It comes down to incredible efficiency and optimized code. They used 992 of those massive 80-gigabyte A100 GPUs.
Okay.
But they also optimized their code base, which they call metaseq, to get really high utilization out of those chips.
I saw that number in the paper, 147 TFLOPs per GPU. Now, for the listener who doesn't speak supercomputer, what exactly are we looking at there?
So TFLOP stands for trillion floating point operations per second. It's basically a measure of raw math speed.
Okay.
And utilization just means how much of the time is the chip actually doing math versus just sitting there waiting for data to arrive from memory.
So low utilization is like a car idling at a red light. You're burning gas, but you're not actually moving.
Exactly. Meta managed to keep the car moving at top speed almost the entire time. They weren't wasting energy idling.
That's super efficient.
It is. But here is the so what of the environmental section. Even at 1/7, the footprint, the energy cost, is still, as the paper puts it, non-trivial.
It's still a ton of carbon.
It is. And that's a huge argument for releasing the weights. If every university and every startup has to train their own GPT-3 from scratch, we are effectively burning down the rainforest over and over again to build the exact same house.
Right. By releasing OPT, Meta is saying we spent the carbon to build this foundation. Now you don't have to.
Exactly. It prevents redundant training runs. It's the reduce, reuse, recycle mentality, but applied to billion-dollar server farms.
Makes total sense. So we know it's efficient, and we know it was really hard to build. But the big question for a lot of people is it actually smart? Like, does it actually stack up against the original GPT-3?
The short answer is yes. When they tested it on standard natural language processing tasks, things like answering questions or completing sentences without being shown examples beforehand, it matched GPT-3's performance across 14 distinct tasks.
So it's a very solid replica. But there was one area where it actually kind of surprised them, right? The dialogue.
Yeah, this was a fascinating detail. Remember, OPT is a pre-trained model. It wasn't specifically fine-tuned to be a chatbot.
Right, it's just raw.
Exactly. It hasn't had human reinforcement learning to teach it to be polite or helpful like the consumer models do. It just read a massive amount of internet text.
It read the whole internet, basically.
Pretty much. But when they tested it on dialogue, actually chatting with a human, it performed competitively with models that were supervised and trained specifically to chat, like BlenderBot 1. It was surprisingly good at maintaining a persona.
I loved the example they gave in the paper for this. They set up a chat where the prompt was a chat between a curious human and the Statue of Liberty.
Right. And the model just rolled with it seamlessly.
The human asks, "Where do you live?" And the model says, "New York City. How long have you lived there?" "I've been there since 1886.
Then it says, "I was built to welcome immigrants to the United States." It nailed the factual history in the voice. It adopted the persona perfectly.
But then the cracks start to show. And this is where we see the difference between a real brain and just a prediction engine.
As they always do with these early unsupervised models.
Yeah, so the human asks, "What is your favorite food?" And Lady Liberty says, "I like ice cream and apples."
A bit weird for a giant copper statue. Maybe she means metaphorically.
Right, maybe. But then it goes, "What is your favorite color?" "I like red, white, and blue." Okay, very patriotic. But then what is your favorite animal? "I like dogs." "What is your favorite song?" And it just sort of dissolves from there.
It devolves into sheer repetition. The paper notes that While the initial persona hold is really strong, unsupervised models like this struggle to keep the magic alive over a long conversation. It forgets it's a statue and just starts answering like a generic internet user.
I like dogs. That's just the average internet comment coming through loud and clear.
Exactly. It reverts to the mean. It stops simulating the specific character and starts predicting the most probable text for any generic conversation.
Which actually leads us perfectly into the darker side of where these answers come from. If the model is just mimicking what it read, we really have to ask, what exactly did it read?
Yeah. Section 4, the dark side. Bias, toxicity, and the pile.
The training data is so critical here. OPT was trained on a mix of data sets. There was the Roberta dataset, the pile, and this is the big one, pushshift.io, Reddit.
Reddit, so it read the front page of the internet.
And all the comment sections, and
Right.
that choice definitely has consequences. There was a really counterintuitive finding in the paper regarding hate speech, actually.
Yeah, this is where the data science gets super interesting. They found that OPT-175B was actually better at identifying hate speech than GPT-3's Da Vinci model.
Significantly better. And why is that? Is it because it has a better moral compass built in?
No, it's
Yeah.
not about morality at all. It's entirely about exposure. The researchers speculate that the reason is precisely because it read so much unmoderated Reddit data.
It knows what hate speech looks like because it has seen a lot of it.
It has a very high familiarity with toxic language. It's almost like an immune system that has been exposed to a virus. It recognizes the pattern immediately, but that is a major double-edged sword.
Because if it knows the pattern well enough to spot it.
It knows the pattern well enough to replicate it.
Right. And the paper didn't shy away from this at all. They openly admit the model exhibits stereotypical biases.
They tested it against standard industry benchmarks. And compared to GPT-3 Da Vinci, OPT showed higher bias in categories like gender and religion. And the researchers point the finger directly at the Reddit corpus for that.
Just reflecting the data.
Yes. It's the mirror concept. If you train a model on internet arguments, it's going to learn the biases of those exact arguments.
Yeah.
We aren't endorsing any of the specific viewpoints in that data.
Yeah.
Of course, we're just reporting what the researchers found the model absorbed.
Right, exactly. And it gets even more intense with toxicity generation. They used a benchmark called real toxicity prompts. Basically, you feed the model a sentence that is slightly toxic, maybe a little mean or controversial, and see if the model takes the bait.
Does it de-escalate the situation?
No, it escalates it. OPT-175B has a higher toxicity rate than other major models like PaLM or Da Vinci. As the prompt gets more toxic, the model follows suit aggressively. It doesn't have that safety filter layer that commercial chatbots have. It just joins right in.
That is deeply concerning from a deployment standpoint,
Yeah.
but also I guess that's exactly why they released it to researchers and not the general public.
Precisely. If this was a commercial product you were selling to a bank for customer service, this would be a total disaster. You can't have your chatbot roasting your customers.
Definitely not.
But as a research tool, this is exactly what the scientific community needs to study.
We need to see the ugliness to engineer it out.
Right. We need to understand how the Reddit data influences the weights so we can learn how to fix it in future iterations. You can't fix what you hide behind an API. By releasing a model that explicitly has these flaws, Meta is allowing the scientific community to dissect the root of the problem.
Okay, let's lighten it up a bit. We've talked about carbon footprints and Reddit toxicity. Let's talk about the quirks. Because for supposed superintelligence, this thing makes some truly hilarious mistakes.
Oh, it really does. These are what the industry calls hallucinations or just limitation failures.
My favorite section of the paper was the poetry. They tried to get it to write a poem about performance reviews.
A topic we can all dreadfully relate to.
Absolutely.
And the content was spot on. It wrote, oh, performance reviews, my performance reviews, how much I dread your yearly meeting.
Very relatable.
Yeah.
It captures the corporate dread perfectly.
Then it says, I think you're out to get me, and it seems like I can never win. It sounds like an angsty employee diary.
But technically speaking, as a poem,
It was a complete train wreck. It had zero concept of rhyme or meter. It was literally just prose sentences broken into random lines.
this reveals something really important about how these transformers actually work under the hood. It understands the semantic cluster of a performance review, dread, fear, meetings, bosses.
Yeah.
But it fundamentally doesn't understand the structural rules of poetry.
Mm-hmm.
It isn't counting syllables. It's literally just predicting the next most likely word based on its training.
So it totally gets the vibe but fails the form completely.
Exactly.
And then there is the math. You'd think a computer of all things could do math.
You would think. And it can if it's simple addition.
Well,
But the paper showed that once you moved to subtraction or division, it completely fell apart.
They gave it examples like, if x is 10 and y is 2, what is x divided by y? The answer is 5. It got that one.
Because it has probably seen that exact sentence 1,000 times in some textbook it read online.
Right. But then they asked, if x is 5 and y is 5, what is x divided by y?
Right. And it answered 2.
2. How does a computer get 2 for 5 divided by 5?
Because it's not calculating anything. It's not running a hidden calculator app in the background. It's pattern matching. It sees numbers, it sees the words divided by, and it predicts a number that often appears in math problems.
Wow.
2 is just a very common answer in elementary math examples.
So it's literally guessing based on vibes again.
It is statistically guessing. It's predicting what a math answer looks like, not what it actually is.
That is such an important distinction for people to understand about these tools. It's not doing math, it's cosplaying a mathematician.
That's a great way to put it. And sometimes even the prompt itself confuses it. There was a weird quirk they found with coding in Python.
Oh, the Python thing. This one completely baffled me.
Yes. So they asked it to write a simple function. And when they changed the variable name in the prompt, literally just the name, nothing functional about the code itself, the quality of the code the model generated changed completely.
That is so bizarre. It's like if I asked you to bake a cake and you did a great job, but if I asked you to bake a gâteau, you suddenly forgot how to use the oven entirely.
It shows just how brittle these systems can be. They are incredibly sensitive to the exact phrasing of the input. It's not robust reasoning, it's highly specific pattern completion. If you step slightly off the path of the specific patterns it memorized, it just gets lost.
And it's not multilingual either, right? I mean, it can't just switch languages easily.
Not really, no. It was trained mostly on English. It can do a little Chinese to English translation, but the paper admits it's very hit or miss. It just wasn't built or optimized for that. Another limitation of the data set.
So let's recap the scorecard here for the listener. We have a model that is a true replica of GPT-3's scale. It runs highly efficiently on 1/7 the carbon. But it can be toxic, it carries bias, it's bad at math, it writes terrible poetry, and it breaks if you change a variable name in Python.
When you put it that way, it sounds like a mess.
But that's the actual point, isn't it?
That is exactly the point. The limitations section of this paper isn't a confession of failure from Meta. It's a roadmap for future research.
So what does this all mean for you listening right now? Why should you care that Meta released this flawed, incredibly powerful thing into the wild?
Because up until this point, the conversation about AI capabilities and safety was happening behind closed doors at a few very rich, very powerful companies. They would say, our model is safe, and we all just had to trust them blindly.
And now?
Now, by releasing the weights and the messy logbook, Meta is effectively crowdsourcing the safety checks. They're saying, here's the raw engine, it has problems, you, the academic community, the data scientists, the critics, you help us define what harm actually looks like inside the machine.
It's democratizing the risk assessment process.
Yes. The paper explicitly states that definitions of risk, harm, and toxicity should be articulated by the collective research community, not just a single corporation.
That feels like a huge, mature step for the industry. Just acknowledging that one team of engineers can't possibly predict every single way a 175 billion parameter brain might mess up.
And it acknowledges that these models are becoming central to our digital lives. We need a broader segment of society to understand them, and you really can't understand what you can't touch.
So OPT isn't the perfect model. It's the model that lets us study imperfection.
Perfectly said. It's a foundational tool for understanding generative AI, warts and all.
Before we sign off today, I want to leave you with a thought. We talked earlier about how OPT is better at spotting hate speech and toxicity because it read so much of it on Reddit. It learned its bias and its flaws directly from the data we created.
It learned from us, the internet.
Exactly. So when researchers dive into this open model to study its dark side, are they really studying the machine? Or are they just holding up a mirror to the collective internet and studying us?
That is the uncomfortable question. The model is essentially just a reflection. If we don't like what we see in the mirror, maybe the problem isn't the glass.
Definitely something for you to think about next time you post a comment online. You might just be training the next superintelligence. Thanks for joining us on this deep dive.
Thanks for having me, and thanks for listening.